everyone could go to the website and go ahead and pull up the problems. Is everyone here for 3004, Electrical Networks? Cool. If anyone leaving early, try to table, I think. If you could just scan the barcode and review, or it's like a survey or something, just go ahead and do that before you leave. And I'll remind you guys at the end of the session too. So.
Where from can I?
All right, does everyone have up here? And just make sure everyone is here for electrical networks, right? All right, I'm going to do, I have about 7 problems. Depending on the time, we're going to maybe do 6. And this is being live streamed, by the way, so try to keep side conversation down a little bit. And then at the end, I'm going to leave about maybe 15 to 20 minutes for questions. And I'm like how to use matrix on the calculator and like imaginary numbers. Just make sure you know how to do all that stuff. All right.
Is this calculator that
Does that have the matrix or the imaginary?
both?
Yeah.
You can?
Yeah, I think so. I'll show you at the end. All right. Let's go ahead and get started. So for this one, we are trying to find Vx using Nodal.
Yes.
What's up? Okay. We're going to start by naming our nodes. We'll name this one. Can everyone see? We'll name this one Vx. We'll have a supernode here. This is our ground. This will be, we'll call this V1 and V2. To start, the first equation we can make is, we have 4 unknowns, right? We have Vx, V1, V2, and I delta. So we're going to need 4 equations. The first one we can go ahead and make is our supernode. So our supernode will be V1 minus V2 equals 20 volts. And then our second equation, we can go ahead and do our KCL from our supernode. So we'll have 1, 2, 3, 4, 5 currents coming out of our supernode. We'll do this first current up here. This node is going to be negative 10 volts. Since the polarity is changed, it's opposite. It's not going to be positive, it's going to be negative. And then, so this current coming across, we're going to have V1 plus 10 all over 10K. Then we're going to have negative 10 I delta plus V1 minus Vx all over 1K plus V2 minus Vx all over 4K. And then our last one, we're going to have V2 over 2K. And this is all equal to 0. So we're going to have to go ahead and get rid of this I delta. Let's make an equation for that one. So our current for I delta is right down here at the bottom. It's connected to ground, so it's going to be V2 minus 0 all over 2K. To make it simpler, we can go ahead and say what our 10I delta is going to be. That's going to be V2 all over 200. If we plug this in, does anyone have any questions about how I'm getting these equations at all, or a question about anything in the equation?
What changed in that?
I plugged in our 10I delta. So now we just have V1, V2, and Vx in our equations. I'm going to go ahead and simplify this equation, just so we don't have any fractions. So what we're going to do is multiply by the least common denominator. That's going to be 20K. So we'll have go ahead and combine like terms. So our V1 term comes out to 22. Our V2 comes out to 85, negative 85. And then our Vx comes out to 25. Does anyone have questions about how I simplified that at all? So now we're still going to need one more equation involving V1, V2, and Vx to be able to solve for all three. We can do the KCL at Vx. So we'll have 1, 2, 3, 4 currents. So this is our final equation. We'll have Vx minus V1 all over 1K plus Vx minus V2 all over 4K plus Vx over 5K plus Vx plus 10 all over 3K equals to 0. This was at our Vx right here. We have 4 currents coming out. So now we want to simplify this one in order to get it into a form like this. We'll multiply by 60K, least common denominator. This comes out to do all this by 60K. So we have 60 Vx minus 60 V1 plus 15 Vx minus 15 V2 plus 12 Vx plus 20 Vx and then plus 200 equals to 0. To combine like terms, our V1 will be negative 60, our V2 will be negative 15, and our Vx will be 1 over 7. So now, is everyone okay with that KCL at that node? Questions? So now this is when all you'd have to do is plug into your calculator. This will be our matrix. This will be our V1, our V2, our Vx, and then this will be our constant at the end. So we'll start with this equation first. So our V1 is 1, our V2 is negative 1, and our Vx is 0. Our constant is going to be 20. Is everyone okay with? I'm simply just using the constants for each variable. Then we'll go ahead and use this equation. Our V1 will be 22. Our V2 will be negative 85. And our Vx will be negative 25. Constant's going to be 0 for this one. Then our last one, we'll go ahead and use this one. Our V1 is going to be negative 60. V2 is going to be negative 15. And our Vx is going to be 107. Constant's going to be negative 200. I think, on this side comes out to negative 20. There's 20 right here. Missed that. Oops.
Okay, so the 3 equations that you used.
Were the 2 KCLs, right? And then we had a supernode. So because of supernode, we have to create another equation from that. Since we had 3 nodes, our supernode equation is going to be the voltage drop from V1 to V2, which we know. Then when we plug this into the calculator, we're going to get V1 is equal to 22.8. Our V2 is equal to 2.8. And our Vx is equal to 11.32. And then to find our I delta would just be 2.8 divided by 2k. Does anyone have questions about?
So, can you show me how to do it?
I'll do that at the end. I'll show you how to do the matrix at the end. But as long as you can set it up into this equation, it's simply just putting it into your calculator at that point. Mm-hmm. Any last questions on this one? Yeah, no, you're fine. Got it? All right. So our next one is going to be a Thevenin's problem. Thevenin's. Okay. This is an 8. So we want to find the max power on the load. So our max power equation is simplified. The first thing we're going to want to do is find VTH. So first we're going to open our circuit from A to B. So as soon as we open our circuit, we can see that our IX current is equal to 0 amps because we have an open circuit. Is everyone okay with that? And then our dependent source over here is also going to equal 0 amps. So let's go ahead and draw. This is what this side of the circuit ends up looking like. We can say our V1 is going to be equal to -2 volts. Our current comes through our the negative end of the voltage, so we're going to call it -2 volts.
Can you say that one more time?
Our current, this 2 milliamps, is coming through the negative end of our V1. So V1 is going to be -2. So let's go ahead and, the only way we'll be able to find our VTH is by doing a KVL in this loop. Since our dependent voltage source is here, we can't simply say that the voltage across the 2 k ohms is our VTH. So we'll want to go ahead and do negative to 0. So our VTH will be equal to negative 10 plus this V2K. So we'll have to find this voltage across the 2 K ohms to find our VTH. You could either do a KCO to find that node, to find that voltage, or you could simply do a voltage division. Because there's no current coming through these 2 wires. These 2 resistors are actually technically in series. So the only place the voltage will be going is to the 2 resistors. Together that Does anyone have questions about the voltage division or why I did it? I did the voltage division on this.
First you have V1 to the rest.
Exactly, our dependent source when we opened the circuit. So then our VTH comes out to negative 5. So to find our RTH, there's 3 options to find our RTH. It's 1, we shut off all the sources. 2, we add a short circuit and use our VTH to find RTH, or we can add a test source to AB and find the ratio of our V test to our I test, and that'll be our RTH. For this circuit, we won't be able to use shutting off sources method because we have our dependent sources. Those won't be able to shut off technically, so we're going to go ahead and do the test. So for RTH using test, we shut off all our sources, we test to AB. This 2 milliamp gets shut off, so we'll have this 8K ohm. To turn off, so you'll have a source. Oops. This will be shorted. For your test, you want your IT coming out of the voltage source. And then this is our 8K, 1K, this is 6K ohms. So basically, we need to get all of our dependent sources in terms of VT and IT, and then we can find that ratio. If you have any like constants without a variable, then you're probably doing something wrong because you won't be able to pull out VT or IT ever from those constants. So let's go ahead and find our V1 of this circuit. Our V1 is going to be positive 2Ix times 1K. And our Ix is right here.
Polarity VT for this source of VT.
Sorry?
What's your polarity for VT?
We have positive over negative.
Oh.
And then we can say that our Ix is equal to our IT. Have both of our dependent sources in terms of IT. Now that we don't really need the left side of the circuit anymore, we can just use the right side. This is 5V1, so it's going to be 10K IT. So one thing we can do is a KVL, or one big mesh, I guess. And our current is going to be IT. To avoid having to do a mesh on this side, we can just put them in parallel since our voltage is going to be the same regardless. So this comes out to now we'll do our mesh. We can start at negative VT plus 10K IT.
Is that a 5 right there on the resistor?
This one?
No, top leftmost resistor on the bottom. 1.5? 1.5?
Mm-hmm. Plus 1.5K IT plus 5K IT equals 0. We can set VT equal to, pull out our IT. We'll have 10K, oops. $10K plus 1.5K plus 5K. Does anyone have questions about the test source? Using the test source, getting it into the ratio?
So when you're doing test source, you're kind of doing like a half deactivation, half, like you deactivate all
Yeah.
the independent sources?
Yeah. So if you ever have a circuit that has sources, like independent sources and dependent sources, you can't just shut everything off and find the RTH through there, because you're still going to have V1, V2, all those variables. So what you'll need to do is shut off the sources and then find that ratio. RTH to current, right?
Right. Okay.
So then all we have to do is use this equation. Our Thevenin's circuit comes out to, we have ohms and then negative 5 volts. So our RL, remember from the original question, is right here. So the shortcut, does anyone have a problem with the shortcut equation? Or do you want me to do it the other way, where this is our VL squared over RL? Okay. This is the derived shortcut. So our VTH is going to be negative 5 squared all over 4 times our RTH. Should come out to, oops. Have any questions about that one? About the test? About the power equation? All right. Move on to number 3. So this one is an Rlc circuit with dependent sources. Does everyone see where our IX is? Oops. This is 30 ohms. So the equation to find VC of t is going to be VC of infinity plus VC of 0 plus minus VC of infinity, and then all that is multiplied by negative t over tau. So the first thing we can do, we'll find our circuit at 0 minus. Find our VC at the circuit where T is 0 minus. So at 0, switch is still going to be opened. So that means there's going to be no current coming through this 20 ohm. So we'll go ahead and redraw our 0 minus. Volts. So our Ix and our 0 minus is 0 because we have this open circuit right here. That means our dependent source is going to be 0 volts. 0 volts will just turn into a short. Oops, my bad. This is open. This is of 0 minus. So now we can go ahead and do meshes. We know this current is 2 amps, right? We could do a mesh around here, and that'll be our I. So we have 15 times our I plus 30 times our I. This is 0 volts, so we'll just have plus 5 I minus 2. Does anyone have a question about the 0 volts or why I skipped the 100 volts? You would have to, yeah. Yeah, you could do that as well. Have your current coming here. So this would be 15 plus 30. Yeah, you could do that. So then our I comes out to, we'll pull it out, we'll have 15 plus 30 plus 5 equals 10. And our I should come out to 0.2 amps. So now that we know the current through our 30 ohm, our 30 ohm is in parallel with our VC of 0 minus. Does everyone see that? This would be a short, and it shares these two nodes. Or, if you're not comfortable with that, you could simply do a KVL here and see that VC equals the voltage over 30. So we know our I. Is everyone okay with how I got 0 minus, VC of 0 minus, using just the 30 ohms? So now we can say our VC of 0 plus equals our VC of 0 minus. Voltage over capacitor does not change instantaneously, so we have this part of our formula so far. We need 2 more parts to complete that equation. So now we'll analyze our circuit at t equals infinity. Anyone have questions about the 0 minus circuit or how I found anything? Okay.
Just to reiterate, after you open a switch
Mm-hmm.
and you took away the capacitor because it's steady state,
Exactly.
you left the nodes there though in your mind because you knew it would be in parallel with the 30.
The nodes of the VC?
Yeah.
Yeah. Yeah, so your nodes are, in case it gets lost in translation ever, just so you see.
Yeah. Okay.
For T equals 0 minus.
So,
Why did we use 30 ohms and not 50 ohms?
because, so you're okay with this being a short, right? So we'll take this out.
Oh, I see. It's the same node.
See it? Okay.
So the 100 volt.
The 100 volts?
Just kind of doesn't matter.
Yeah. Even if you're like a little bit iffy on why it doesn't matter, you could try looking at the KVL, like including it in your KVL. So you'd go up VC, so you'd be negative VC plus the voltage over the 30, and you'd use this node, so you go up 100, so negative 100, and then you'd have to come down. It's the only way, so it cancels out, essentially.
Doesn't matter though when we start doing the infinity because we've closed the switch though, right?
Yeah, at the infinity, we'll have to use it.
Okay.
So let's go ahead and draw our infinity circuit. We have our 2 amps, our 10 ohm, have our 15, and our capacitor is still going to be open. So let's go ahead and keep those nodes to remember where it is. Then our switch is going to be closed. So we'll have this resistor, and we'll be using this voltage. And our IX is now not 0. This is 10, 5, 15. So now it's just analyzing the circuit. You could either use mesh or node voltage. If we use node voltage, this whole entire node right here is going to be equal to VC of infinity. Is everyone okay with that? Calling that VC of infinity? Oops. So 2 amps. we'll have to add one more unknown to use node voltage. So we can put our other voltage right here. We'll call this V1. So our unknowns, we have V1, VC, and IX. So we're going to get equations. One of the equations we can get is our dependent source. So current V minus 100 Is everyone okay with me using the, where I got this equation from? VC minus 100 instead of VC minus 0, or doing two different nodes and splitting it up? Because this is technically VC minus 100 minus 0. So it's the whole entire voltage drop. So then, we can go ahead and get our, we'll be using a matrix for this one. So this is our VC, oops, we'll do V1. It's fine. VC, V1, and our IX. So if you multiply over the 20, IX minus VC, so we'll have negative 100, 20, negative 1, and 0. Now we can do a KCL at our V1. So we'll have 1, 2, 3 currents at our V1. So we'll do, we know this current coming in is 2 amps. So if we want to declare it as going out, we can say negative 2 plus V1 over 5 plus V1 minus VC of infinity all over 15. So we can, to simplify this, we can say 2 equals V1 over 5 plus V1 over 15 minus VC all over 15. We can multiply both sides by 15. This will become 30 plus 3VI plus VI minus VC infinity. Put that in our matrix. We'll have 30 as our constant, 4 as our V1, and negative 1 as our VC. So we'll need one more equation. We can do a KCL at this node. So we'll have 1, 2, 3, the Current, obviously, at the open circuit is going to be 0, so we'll only have 3. Currents, we'll do Vc of infinity minus V1 all over 15 plus Vc minus 100 all over 20 plus Vc minus 2Ix all over 30. This is all equal to 0. Plug in your Ix, this equation, into this form, or no, you don't even have to do that, sorry. Simplifying it, you should get 9 Vc minus 4 V1 minus 4 Ix equals 300. So we plug that into our we should come out to get our Vc of infinity to equal 39.7 volts. Does anyone have a question about how I found Vc of infinity? Yeah? Which part?
So after I understand what you did to get the equations down there.
Down this one? And then you don't know how to do that one?
Yeah, what did you do to get up?
That one? I did, this node is Vc, right? So I did this current. So we have Vc minus V1 over 15, Vc minus this voltage all over 20, all over 30. Yeah, or it depends on what you say a supernode is. One big node, yeah. So now we have this part, and this part of your equation. The only part remaining is our tau. So usually to find tau, we shut off our sources, and then we have the switch at 0 plus. So the circuit's going to be, or the switch is going to be closed. But in this problem, we have this dependent source. So if we shut off the sources and closed it, we'd actually still have this dependent source that we wouldn't be able to put into ohms, right? So what we'll do is we'll have to attach a test like we did to find RTH in the last problem. So our circuit, we'll still set off sources. This 10 ohm is going to be out because it's an open circuit, so I won't include that into our new circuit.
This is all just to find our equivalent.
C tau is equal to Req CEQ. And we know our CEQ. We'll just have to find our R equivalent. Where our capacitor is, or your inductor. If we were finding our R equivalent without a test, we'd be looking in through the capacitor and through the inductor, right? So what we're looking into is where you want to put your test. This is 15, 5, and our switch is going to be closed, and our sources are going to be off. So this is a short. Our dependent sources do not turn off because our Ix is still here. It's still a value. And this is our 30 ohms. And then this is plus minus, sorry. So this whole entire node, again, is our VT. So we could actually just, these two added is 20. So we'll just do a simple nodal analysis. We'll have VT all over 20. We can say at the end equal to IT. And then we'll have VT over, this is 20 as well. And then we'll have VT minus 2IX all over 30. So we'll have to put our IX in terms of IT or VT. So our IX is actually just VT over 20.
Just did KCL of VT.
Yeah. And we know this current is IT. So although we have a voltage source, we don't need to make a new variable. So when you plug it into here,
Sorry, how did you know IX equals VT over 20 again?
our IX is
Oh, I see.
right here, right? So when we plug everything in, we should get, we'll do the least common denominator, which is 60. We'll do 3VT plus 3VT plus 2VT minus 4IX is IT 60. Your final ratio equation should come out to 7.8 VT equals 60 IT. So now you want that ratio. We'll do VT over IT equals 60 over 7.8. So our REQ should be 7.7 ohms. So then our tau should come out to 7.7 capacitor we have, right? So it's 0.1 micro. Is everyone okay with how I got REQ? Cool. So then we want to find our final, the question asks for VC of t. So we want this final equation. C is our infinity. Our infinity was 39.7 plus our 0 plus, which was 6 minus our infinity. Then we have e to the negative t over our tau, 0.77 micro. And this is volts. Is everyone okay with that equation? How I got it? Any questions?
Just show the when we were doing the test voltage at nodal.
This one?
Yeah.
Mm-hmm. Okay. Our next problem is going to be an RLC circuit. I just wanted to go in order. I didn't put those in order. I'm going to do the one before that after this one.
One number 5.
Yeah. So at t equals to 0, our switch goes to B. Sorry, I did not have room. This is our capacitor value, and this is where our VC is. So with RLC circuits, the first thing we're going to want to do is find out if it's in series or in parallel. To do that, we'll put the switch at t greater than 0, and we'll shut off all of our sources. So at t greater than 0, our switch is going to be on this side. We can just go ahead and ignore that side of the circuit. So we'll have this in parallel with the 4K. Oops. So our 4K is in parallel with a short. It's going to get canceled out, so we'll actually just erase it, and we can see that our circuit is in parallel. Does anyone have any questions about how it's in parallel? We have our capacitor, our resistor, and our inductor.
This is at 0 minus
0 plus.
0 plus.
Because at t equals to 0, close to B. So, since it is in parallel, we have our, next thing we're going to want to find is our alpha and omega naught. Our alpha is going to be 1 over, so our R in this sense is just our 1K, because that 4K got canceled out. So alpha is 2RC, 1 over 2RC, so 1 all over 2, 1K, 6.25 nano. This should come out to 80,000. Our omega naught is 1 over square root of LC. Our L is 16 micro times 16.5 nano. This should come out to 100,000. So now to determine if it's overdamped, critically damped, or underdamped, we compare our alpha to our omega naught. So in this circuit, our alpha is less than our omega naught. This means that our circuit is going to be underdamped. So with underdamped, we use omega D. Let's go ahead and find that now. It's going to be the square root of omega naught squared minus alpha squared. This should come out to 60,000. So for all we have we have I of t equals I steady state plus I n. We can first find our steady state, which is just infinity at t equals infinity. We can do that. This one? This is just known for RLC circuits. Like if voltage of t, the VC of t, it would still be steady state plus natural. It's that exponential decay thing. So with steady state, we want to find it. We want to find IL of t at t equals infinity. That means our switch will be at B. So we'll have this short with the 4K. And all of our components will be turned off. So we'll just have this open circuit of VC and our IL. So both of our VC of infinity and IL of infinity are 0. Does everyone see how it's 0? Why it's 0? We don't have any sources or any power in this. So basically, we have nothing here. This is shorted out. This becomes a short. This becomes a short. Basically nothing. So we know this is just going to be 0 plus our natural. And for underdamped circuits, our I natural, the equation for this is e to the negative alpha t omega d t plus a2 sine omega d t. This will be in amps. Does anyone have a question about that equation? Everyone knows this is familiar, right?
I have a question.
Yeah. Yeah.
How did you determine that VC infinity is 0 volts? How do you know that it's 0 volts without calculating the energy?
Well, if you you're okay with this becoming a short, right?
Right.
So then our VC also in parallel with a short. So we can just wipe it all out.
Okay. Sorry.
No problem. So is our I of t is just going to be equal to our natural response. So we can find the circuit at t equals to 0, and we'll be able to get our A1. But then to find our A2, we're going to want to find the circuit at t0 plus to find our VL of 0 plus. And this is all equal to alpha A1 plus omega D A2. These equations are actually all in the book on how to find A1 and A2. They're like quick. Huh?
Do you know the page number by any chance?
I could find it at the end for you
Yeah.
if you want me to.
It's like at this chapter review.
Yeah.
Chapter?
It's like right before the questions. It has like literally all of them listed.
I'll find it then. Thank you.
So first let's find 0 plus, which equals to 0 minus, for our inductor current. So our circuit at t equals 0 minus. We have the switch is still at A. We have this 4K, 1K. Our capacitor is open. We're going to want to find VC of 0 minus because it'll help us in our VC of 0 plus, finding the current of the 0 plus. And then our inductor is shorted. So this voltage across the 1K ohm is still the voltage across the 4K ohm, right? See how those can find VC of 0 minus? Also, we can combine these two, because even if we combine them in parallel, the voltage is still going to be the same. So we'll get a simple circuit of this, and this should be 800. Yes, 800 ohms, 400 ohms. And this is our VC. Is everyone okay with me combining those two, calling that VC? So we can use voltage divider to find our VC of 0 minus, which will be negative 360 times 400 all over 1200. This should come out to negative 240 volts. Does everyone see why I put that negative sign in front of the voltage divider? No? So the polarity of VC is flipped, and our voltage divider assumes positive, negative, positive, negative. So all we'll do is add the negative sign, or if not, if you wanted to find just the voltage across the 8 ohm, our VC would be the negative of the voltage across the 8 ohm. So then we can our IL of 0 minus. So our IL of 0 minus so we can take Ohm's law. We'll have, it's going through the negative terminal, so we'll put our negative here, times our voltage. Negatives cancel out, and we will get 0.24 amps. Everyone okay with that? I down. So yeah, it's coming down this way, so it's going into the negative VC terminal. So those negatives just end up canceling out. So we now have VC of 0 plus and IL of 0 plus. This is equal to negative 240 and 0.24. A1. So our IT, our I of t, is technically just equal to I of n. And our I of n, where t equals 0, exponential function just turns to 1. We can ignore that part. So we have a1 times cosine of 0 just turns to 1. And then plus a2 times sine of t, which is just 0. So our a1 just equals IL of 0 plus. Is everyone okay with that? So now that we have our A1, the only thing we are missing from this equation is our A2. So to do that, we'll use this formula, the voltage over an inductor formula. So we'll need to find, this is derived. This equation is the derivative of this equation at t of 0. So this is just derived. So all we'll need is the voltage over the inductor to complete this. So we'll have to draw our circuit at 0 plus. It'll end up looking exactly like this one, because our switch goes to B, so this is shorted out. We only have this 1K and this inductor and this capacitor. So we can draw our circuit. This is plus minus VC. Here's our IL of 0 plus, and this is where our VL is. So these are all in parallel. So our VL of 0 plus actually just equals our VC of 0 plus. Is everyone okay with that? Cool. So we'll plug this into our formula down here. Our L is just our inductor, so 16 millihertz, negative 240, yeah. 16 mil equals our, which is, what am I doing? Times our A1, we found our A1 was 0.24. Plus our omega D, which was 60,000. A1. I mean A2, my bad. So our A2 should come out to 0.07.
I have a question again.
Yeah.
I don't know if I made this being silly and forgot, but on the bottom left of your paper, you said that DIL over DT is VL 0 plus over L. How did you determine that again?
So the voltage over is yeah.
For VL.
Yeah. So we simply just, this is this derivative is how we get this formula. So then we just need to find our VL over our L. Mhm. So then all we have to do is plug this back into our formula. Since our IT is only our natural response, we have e to the negative alpha, so ADK, t times our A1, 0.24, cosine times our omega d, 60k t, plus 0.07 sine omega d. This is amps. Does anyone have any questions about that one, the RLC circuit? No? Okay. So now we'll go ahead and do the one I skipped. This is the one I skipped, right? Okay. I said to find the Thevenin's equivalent, so the first thing we're going to do is our VTH. All of this is our VTH, and we can actually say our VTH is equal to V2. So that'll take care of one of our dependent sources. And our I phi is across this 200. So we'll do let's go ahead and do this KCL at our VTH. So we'll have 1, 2, 3 currents. This is VTH minus VTH over 5. Is everyone okay with me calling this node VTH over 5? Because our V2 is equal to VTH. Over negative J50. We'll have plus 88I phi plus VTH over 10. That's one equation. One to get that I phi out. Our I phi is actually just equal to 5 minus VTH over 5 all over 200. This node is 5. Once you plug your I phi into this equation, you can actually just pull out VTH. We won't do the algebra, but it should come out to, once you pull out VTH after plugging in I phi, it comes out to 0.02J minus J004 equals to negative 22, or 2.2, my bad. So our VTH after solving this comes out to negative 66 plus J 88 volts. Is everyone okay with the circuit analysis on this one? Simple VTH. Now for this one, we'll have to find our RTH as well. Again, we have dependent sources, so we cannot do deactivation. We could, I also don't think you'd be able to use a short because everything would cancel out. So we'll go ahead and use our test. We turn our sources off, so just have this 200. And this is where our test goes. We have plus minus VT, IT. So this is, again, all of VT. This is VT over 5. We can just do KCLs again. This is our IP. So our IT, we'll say what's going in is equal to what's leaving. IT is equal to VT over 10 plus 88 I phi plus VT minus VT over 5 all over negative J50. We'll have to find an equation for our I phi again in terms of VT and IT. We can have this current right here. So we'll have negative VT or all over 100. Negative VT over 1,000. Which one? Phi are, that's the current over this resistor right here. So remember with how we do nodal analysis, it's the voltage over the voltage drop over the resistance. So this current coming out is VT over IT all over 200, and then I just put the negative to flip the sign. Yeah. So when you solve IT into here, you should get the final ratio 1000 plus 1 over negative J50 plus 1 over 5 all over J50 for IT. Equals T. We'll go ahead and transfer our VTH into angular. We'll get the magnitude as 66 squared plus 88 squared. And then our tangent of 88 over negative 66 should come out to 110, angle 126.9 degrees. Our Thevenin circuit will have this will be our real part, this will be our imaginary. Is everyone okay with that? It's just Thevenin, but using imaginary. I did the that's the angle of this. You'll have to be careful when, negative. You'll have to be careful when putting it into your calculator because the unit circle where x is negative and our y is positive, that's the second quadrant. So whatever angle you'll get, you'll want to have it in that quadrant. Your calculator doesn't account for that stuff. Okay.
Go back.
Yep. Good. All right. So for the next one, we'll have to transform our circuit. So the capacitor on top, 100 micro in impedance is negative J all over, our frequency is 2500. It's our frequency times our capacitor, so 100 micro. This should come out to negative J4. Our next capacitor is 50 micro. This should come out to negative J8. Our inductor is J times our frequency times our inductor. This should come out to J4. Everyone knows where I'm getting these equations from, right? Changing it to impedance. Okay, and then our sources, our current will just be 5, angle 0. Our voltage will just be 20, angle 90, which is oh wait, 12K, I mean 12. Does anyone have a question about transforming it at all? Everyone good with that? All right. So we want to find O, which is over the inductor. We can do KCO. We'll have this node. We know this node, right? And then we'll have this node. So we'll do V1, V2. V1 will have 1, 2, 3 currents. So we'll do V1 minus V2 plus V1 all over plus minus J20. Everyone can see how this is equal to J20. Does everyone know how I got J20 from this angular form? So that's our first equation. Our next equation, we'll do V2, KCL. We can do incoming is 5 equals what's leaving is V2 minus J20 all over negative J4 plus V2 minus V1 all over negative J8. Everyone okay with that, KCL? Then you'll have to do some algebra. And you should find that your V1 is equal to negative 8 plus J4 volts. Is everyone okay with that? So then we have this voltage across the inductor. All we would have to do is a simple Ohm's law. So our I.O. is equal to, this would be I, capital I, V1 all over J4 equals negative 8 plus J4. This comes out to 1 plus J2. So now to put that back into time, 1 plus J2 equals the magnitude of 1 squared plus 2 squared, 2 over 1. This should equal 2.24 with the angle 63.43. That would be our magnitude. Cosine our frequency was 2500, and our angle amps. Does anyone have questions about how I transformed that? Brought it back. This is the magnitude, and this is your angle. Yeah, good. Okay, so our last question. I have to use this paper. So we're asked to find RO. Our RO is the magnitude of our ZTH. This is in VRMS. So to find RTH, I'm going to use a short with our VTH. So first we'll find VTH. This is our V phi. Here, 1. So V phi minus 100 all over 5 plus V phi all over J5. And then our current, remember VTH is an open circuit, so this dependent source current up here is actually current coming in here. So we can do minus V phi all over 10. We'll need one more equation to involve VTH with our VP. It'll come out to VTH is negative J5 times our current. This is V phi all over 10. And then plus VP. I just did a KVL here, so negative VTH plus, we know the voltage because it's the current times the capacitor, and then plus our VP. Does everyone know?
You did that to find VTH.
Yeah. I needed a formula. I needed an equation to connect them. So then pull out, our VP should come out to 40 plus J80 in VRMS with algebra on this one. And then we'll plug that into our VTH equation. If you pull out V phi, you get negative J5 all over 10 plus 1. Then you just multiply these two together and you'd get 80 plus J60 VRMS as our VTH. Then we'll do our short circuit. So our ground's here. This node, this is our ISC. This node right here is at 0 volts. It's on the same node as the ground. So all we really need to know is this V phi. So we can do a KCL at this node. We'll have incoming as V phi over 10, our dependent source. Another incoming is V phi over negative J5, and then coming out is our ISC.
Sorry, again, where did you get to VP over 10?
Our dependent source. Then we'll need an equation for to get V phi. We'll do our KCL one more time. We'll do V phi minus 100 all over 5 plus V phi all over J5 plus V phi all over negative J5 equals to 0. I did our KCL at our V phi. Our V phi should come out to 100 V RMS. Plug that into here. Our ISC becomes, if you pull out V phi, you get 1 over 10 plus 1 over negative J5 equals ISC. You multiply these two together to get 10 plus 20 RMS. To find RTH, simply VTH over ISC. So our VTH is 80 plus J60 all over 20 plus J20. This should come out to 4 minus J2. And like I said, oh, this is CTH, my bad. Our RO is the magnitude of ZTH, which is 4 squared plus 2 squared. Comes out to 4.47 ohms. We will get our Thevenin circuit. This is our RO, 4.47 ohms. This is our negative J2 ohms and our 4. That's from our ZTH. And then our VTH is going to be 80 plus VRMS. To find the power of this, you would have to, or you could just simply do a one mesh. This would be your I. And then you'd get negative VTH plus 4I plus negative J2I, and then plus 4.47 I equals to 0. You'd get your I equal to 7.36 plus J 8.82 in RMS. And then your power equation is just simply you want the magnitude of your current squared times your RO. The magnitude of this should come out to 11.49. You'd square 7.36 plus square of 8.82 and then square root of that. And your power should be 790 watts. Does anyone have a question about the circuit analysis or equations? Obviously, there's a lot of
What 90? Is that J?
5,
5.
590.
Okay.
Yes. And then we'll want to find
Is what we're doing here finding real and reactive power just separately? Is that what's going on here? Like with
the next one we find the active power, right?
Yeah, we're just doing it separately instead of in one big equation. Right.
They're power, or like multiple different kinds of power.
Okay, we just learned it a different way in class. I was trying to connect the two.
Yeah, the next one we find, where'd it go? So then it wants the power of Z low, or the load. And Z load is the conjugate of our ZTH. So our Z load will just be this will be positive for an inductor because it's positive. J2, 4 ohms. So then again, we do, this is our VTH. We would just do a current to find, should come out to 10 plus J, 7.5 in RMS. And then for this power, we just want the power of our inductor will be 0 for this one. So we'll want the magnitude, again, the magnitude of the current squared. So times our real part, because only the resistor will have power. Only our resistor will have average power. Our inductors, average power is 0 always, so that's why we're only using the real part, which is our resistor. Is everyone okay with that? It's just like a known thing that our capacitors and inductors have 0 average power. Yes? Okay. We only have about 13 more minutes. So, does anyone have last minute questions? Yes?
When you calculated ISC, you had it as V phi over 10 plus V phi over negative J phi, and then you ended up with 10 plus 20J. How come it's not 10 minus 20J?
For ISC?
Yeah. You have V phi over 10 plus V phi over negative J phi.
Because 1 over negative J,
J is a negative 1 then?
yeah,
Oh,
yeah. So the signs get flipped, but
But there again, when you do your PCL, that's 10 plus J 7. No, this is, how do you get this?
I just did a KVL.
Wait, where is that? 10, right? And this is in the jets. This,
Yeah,
okay.
yeah. So I'm going to show you guys how to do the, this is really blurry, but I'm going to show you guys how to do the matrix. So find your matrix button. It's probably second matrix. You'll come to a screen like this. You want to go to edit. You'll fill in so this matrix is 9, negative 4, negative 4, 1, 0. So this is what our matrix looks like. And remember how on the first problem, I was getting constants with our terms? And this is our C. So when you plug this into the calculator, it's going to give you a matrix that looks like this. And this will be V1, V2, and V3. So to put the values in, you want to go to Edit. Then you'll have your 3x3 or 4x4, 2x2. You'll put in every single one. This is your V1, V2, V3. And then to put in the constants, it's your 3x1. So your matrix B. This is your first equation constant, your second equation constant, and your third equation constant. You want to keep them, obviously, in the same pattern. To perform it, to get the answer, you use your A to the negative 1 times your matrix B. And then it'll bring you, this is your V1, V2, and V3. Okay, this is how I do it. So I was just showing. So, and then to use imaginary in your calculator, you go to mode. You go all the way down. There's real, A plus BI, and your magnitude in your angle. You go to A plus BI. You'll just have to be really careful with your calculator using imaginary. You just have to spoon feed it. If you do 1 over negative I5, it'll give you 5I. But the real answer is negative is 0.2I. So just make sure you're using your parentheses because it'll flip it. It'll do them separately. Especially if you're using equations, just spoon feed it everything. Okay. Does anyone have any other questions, random questions? If you don't, please do the surveys. They're at the end of the table. I'll pass them around. All you need to do is scan the barcode. Here you go. Yeah.
I still don't really understand how you got the 7.5 into here. Are you just adding these two values? What?
7. If anyone has any last-minute questions, I'd make sure whatever you brought, you take it home and don't leave any trash, please. Yes. Yeah. Jeez. I'm all over the place, sorry.